let's look at the workbook questions. I think I've not yet gone through this two, right? And then I remember there was an error in another question as well. Correct? Which question was it again? 2B. Okay, later on I'll go through that one. Okay? Let me just write that down. Okay, now let's look at 3C. Okay, so what should we do first? What have we learned? Let's do a recap. When we have a fraction like that, okay, what do we need to do with it? Remove the brackets, okay, so that means we need to expand. Do the expansion first. Then after that, what is the denominator that we will take? 10, okay. Last lesson, I think I also pointed out that it's important for us to put in the brackets, although there is no change in the denominator in this case, because really speaking, it is a multiplication of 1. Alright? And especially it's important, okay, when down here is a minus sign, because it will cause the operation to change. Alright? And then we get 10h plus 1 over 10. Okay? I remember that the other day when I was walking around, okay, Brian did ask a very good question, okay, whether we can further simplify this fraction and cancel out the 10 like that. Okay? The answer is no. Okay? Because there is no common factor in the entire numerator. Okay? We will address about simplification of the fractions when we have covered our factorization. Okay, so at this point, my answer is just no, you cannot cancel in this manner. Okay, any questions? Right, so the answer will just be 10h plus 1 over 10. Okay, next, looking at part D. So similarly, we will expand the brackets first. Okay, so 3k minus 3 in the numerator. Then after that, denominator likewise we will seek for 10. And then we will get negative 9k plus 7 over 10. Okay. The answer that was presented for 2B. Okay, even myself, I think my answer was not sure why that happened. Okay, so 1 quarter x minus away 1 over 8x, that will give us 1 over 8x. And this should have been plus 7 over 12y. Okay. Right, any questions? Okay, if not, let's go back to our worksheet. Okay, we'll be looking at 1.2 today. there is no equal sign, okay, there is no value given to that expression at all. Okay, so we looked at expressions and then their fractions. So now we will be looking at solving linear equations in one variable whereby there are fractions inside it. Okay, so looking at example 3a, you want to learn how to solve this. Okay, in your notes itself, right, I have printed out such that the design is having two columns. Okay, so I will show you alternative answers after that. Okay, because there are many ways that we can do solving. Okay, but let's focus on the main objective. Okay, our main objective is always to find out what is the value of x. Okay, and last year we said that we always keep what on the left? What do we keep on the left? The algebra on the left, right? Okay, all the variables, and then the numbers on the right. Okay, so that is always the procedure and the way that we want to approach it. So in this case, what will you have done first? This is x over 2, is no different from half x. Right? So what will you do first? Yes, right?
You can make the 3 into a fraction.
Make the 3 into a fraction. Okay, any other ways then? Is it necessary for us to make the 3 into a fraction? I think there's other more elegant kind of process. Okay, move the 3 to the right. Yes, alright. I think that might be simpler than having to introduce more fractions into the fraction. Okay, although Ryan said whatever that Ryan said is not wrong. Okay, so we can have x over 2 equals to 6. Right? So x over 2 is the same as half times x, half of x, or it can be also the same as x divided by 2. So what do we do to the 2? Yes, times 2, okay? So we can times 2, right, over to the right, and that will give us 12. Okay. I will go on to the alternative answer first, okay, which is actually what I want to present according to what Ryan has mentioned. Okay. Next, we look at part B. Give some space first. That we can do part B, right? Can someone recommend one of the ways that you're thinking first? What do you think you would have done? Liana, what do you think you would have done? Then? Okay, very good. So you want to open up the brackets and do expansion first, okay? Sure, you'll do that approach. Okay, so half times 1, then after that half times negative x, so I put the negative sign outside already. So essentially, okay, this is what we're getting. Okay, you can write it as x over 2 or half x. Both mean the same thing. Okay. Then what next? Willa, what do you think? What will you do next? Equals to 3x, Okay, great. So you want to shift the half x to the right. Okay, so half equals to 3x plus half x. Okay, and keying that into your calculator, you will get 3.5x or 7 over 2x. Right? So therefore, half equals to 7 over 2x. How do we proceed next? Actually, what do you think? Sorry? Times 2. What do you mean by times 2? Times 2 where? To what? To the half? Then? Yes, now half divided by 7 over 2. Half divided by 7 over 2, okay? Yes, you can do that. The reason is because 7 over 2 times x. Okay, this is what it means. So if there's a times over here and I want to bring the 7 over 2 to the left, I will do a division. So half divided by 7 over 2, I will get the x on the right. Okay? So in this case, if we are keeping the algebra on the right and the numbers on the left, which is also fine. Okay, as long as one side, because after all it's equal. If the left side equals to right, right side also equals to left. So half divided by 7 over 2, that will be 1 over 7. So 1 over 7 equals to x, x will be equals to 1 over 7. Right? So this is one way of doing it, whereby at the beginning, we started off with expanding. Right? Would anybody have other suggestions on what would you have done? Any ideas? Instead of doing expansion. Okay, let me read this out for you. This is half brackets, right? Brackets means that it's times, right? Half times 1 minus x together. 1 minus x together. So I would have seen this as half times 1 minus x equals to 3x. Okay, yes, right. Divide what? 3x divided by? Sorry, I can't catch it. 3x divided by 1 minus x. Okay, good try. Okay, how about we do another thing, times another number or something else? Because 3x divided by 1 minus x, end up, I don't think you'll be meeting your objective very quickly. 3x divided by? Why divided by 2? Times 2. Okay, so why is it that you're saying times 2? 3x times 2? Because it's a half. Okay, so what we could actually do as well is that we leave the 1 minus x behind. We take 3x divided by half. Divided by half is the same as times 2. Okay, so that will be equals to 6x. So that's how we actually get 1 minus x equals to 6x. Right? And then very simply, okay, we can take minus x shift to the right. And we see that 1 equals to 7x. And therefore, x is equals to 1 over 7. Okay. So we may see that this alternative answer over here is could be shorter than what we have done in part B. You can write your alternative answer in the other part of the box. Okay, any questions? Right. So I really try to expose you, okay, many different ways of doing things. Okay, you're not restricted to just having a fixed method. Okay, because if you think that any equation there's only one fixed method of solving, okay, then you're going to memorize a lot of processes. Okay, you really need to understand why and how we bring numbers across equations. Okay. Next, in part C. Okay, for part C, right, okay, we will do a very special kind of method, okay, although it's actually very logical, whereby, okay, we will do this thing called cross multiplication. Okay, so actually, because it's 5x minus 1 divided by 3, to get rid of the 3, I times 3 on the right, times 3 on the left. And then after over here, this is 3x plus 1 over 2. Okay, so I times 2 over here to get rid of the denominator 2, and I times 2 on the right. So essentially, I'm doing a cross multiplication such that I will achieve this. Okay, so this is the whole idea about cross multiplication. But there are certain fixed conditions in doing cross multiplication. Okay, I cannot do cross multiplication when there are more than one fraction on each side of the equal sign. So there must only be one single fraction on the left and also one single fraction on the right. Okay, I cannot do cross multiplication if I something like that. Okay, whereby there is more than one fraction on either one of the side. Okay, so cross multiplication only when one fraction equals one fraction. Okay, clear? Right, but although definitely there are ways to get around it. Okay, but we're not going to look at it now. So continuing from this step over here, okay, we will do the expansion. And then we have 9x minus 10x equals to 2 minus 3. And so we have negative x equals to negative 1. Is that all of our answer? So, okay, no, because we need to get rid of the negative. So I times negative 1 over or divide negative 1 over. So it will be x equals to 1. Okay, so that will be the answer. Yes. Yeah, I copied wrongly. Oh, okay, on this one. Sorry. I will give you alternative for part A, right? Okay, so I was holding on to what Ryan was saying just now, whereby make the 3 into a fraction. Okay, so alternatively, we understand that 3/4 is 3 over 1. We could make this into a single fraction. And we get x plus 6 over 2 equals to 9. Okay? And then we can multiply 2 over to the other side. Okay? We can see as cross multiplication as well, whereby it's 9 over 1. So it will be x plus 6 equals to 9 times 2. Get the x is equals to 12. Okay, you will find that this process is slightly lengthier. Okay, not as elegant as how we actually do this part. Right? Okay. Any questions? If not, let's turn to your workbook. I'd like you to do exercise 1B. Question 1A, 1B. 4. So it is a negative number over here. So B would have been negative 4 divided by negative 3 over 14. Okay? Whereas what was presented here is that it is a positive number. So technically the answer should have been a positive 18 and 2 over 3. You understand? Okay? Remember, this is the negative number. It is not an operation sign. It's not a minus or plus. Okay, next in part C, right? Answer very well done. Just that there are some unnecessary steps. Okay, so 5 quarter C minus 2 quarter C, I believe, because calculator was not brought up. Otherwise, you have just minus away half C. Okay, and then you figure that it's 3 quarter C. You could use your calculator in doing that. Okay, then after that, 5 is equals to 3 quarter C. Right? Then we just can find that C will simply be 5 divided by 3 quarter. So pressing the calculator, you would immediately get that C is equal to 20 over 3, otherwise 6 and 2 over 3. Either answers are fine. Okay? Next, part D. Part D, we will do cross multiplication. Up to this step, expansion is fine. But then at this final step over here, okay, at this step over here, something is not right. Okay, what is not right? 3 times 3. The minus 3. So what should it have been? Plus 3, okay? Because over here is a negative 3 minus 3. So bring across, you have been a plus 3. Okay? So technically it is 6D minus 2D equals to negative 8 plus 3. Sorry? 9D. Oh, yes, 3 times 3 is 9. Oh, sorry, even myself. Okay? So 9D minus 2D is equals to negative 8 plus 3. 7D is equals to negative 5. And D will be equals to negative 5 over 7. Okay? Any questions? Alright? Okay, now let's go back to our example 4. Okay, so for 2A, right, okay, I have an issue, okay, in the working that is being presented over here. Wait, let me check answer first. Okay, I have a very big issue with this. Why is it 3 times 1? Yeah, cos what? It's a question different from mine. Why 3 times 1? Okay. So 3 times 1 not correct, right? So what should it be, Peter?
Oh wait, oh yeah,
8 times 1.
Should I be 8 times 1, right? Okay. Alright, so 8 times 1. Okay, then just now Peter also included this equal sign over here. They are not equal, okay? So therefore don't put the equal sign on the left. They should all be in the center. So therefore 8 then equals to 8W minus 12. Then after that it should be in an 8. This is a 20. 20 divided by 8. And answer should have been 2.5, right? Okay, 2.5, 5 over 2, 2.5. They are all the same, right? Next, okay, at part B. Okay, steps here, these 2 steps are correct. But over here, there's something not right. Okay, what was presented in case you can't see? Okay, this was the step that was presented. What is not correct? The 6, okay, should have been a plus 6, right? Okay, so should have been a plus 6 because this is a minus 6 over here. Bring it to the right, should have been a plus 6. Okay, and this would have been an 18. Okay, so answer should have been negative 18. Alright? Next, looking at part C. Okay, part C perfectly done. Answer should have been negative 1 and 1/3. Okay, do give a check of your answer. Okay, so in part D, right, when you see that there are numbers, okay, and it hinders you to cross multiply, what you should do is that you bring the numbers together. Okay, it may actually then help you to form your fraction and do your cross multiplication. Okay, so sometimes bring things over may help you to get the format that you need to do cross multiplication, which is always single fraction equals to single fraction. Okay, and then after that you can expand and simplify. Part D also perfectly done. Okay, same thing, negative 3, bring it to the right. Okay, and then after that you solve, expand, simplify, and solve. Okay. Any questions? Right, if not, we will continue with this next lesson.